morning. Thank you for joining our session to talk about integrating your smart home devices with the Google Assistant. I'm Mark Spates, and I brought a few of my colleagues with me.
I'm Michele Turner. I'm the director of the smart home ecosystem.
And I'm David Schairer. I lead engineering for smart home on the Assistant.
Awesome. So when we started this project a couple years ago, we had a vision. And our vision was to have the Google Assistant be the center of intelligent interactions with IoT devices. We selected the word intelligent for a very specific reason. We believe that users would demand that their assistant in their home understand the environmental context as well as the device capabilities when they start to control these devices. To achieve this goal, last year, we launched the ability for developers like yourself to integrate smart home devices using the Actions on Google platform. Just a quick reminder, Actions on Google is our platform for developers to create experiences around education, games, and many others through the Google Assistant. When it came to smart home, one thing that we focused on was having a seamless, easy experience for developers to connect these devices to the Assistant. We also understood that we had to allow this contextual understanding that we were gaining from the home and devices to also to be accessible to our developers. With that, we also created the home graph. This is a very simple visual representation of the home graph. The home graph is the key to these intelligent interactions that we have with users. I'll just walk through it quickly. If you look at it, it's broken down into three main parts. The first part is the structure. Understanding the structure and the name of the structure, the address of the structure, who's in the structure, what rooms are in this structure, what devices are in this structure, is there anyone home, what's the presence of this structure. Then the next thing that we look at are rooms. Rooms are extremely important signals when you think about interacting with an assistant when it comes to contextual relevance. A command in the living room versus the kitchen can mean very different things. So when you look at the room level, we're saying what is the name of this room and what devices are in this room. The third, and probably one of the most important components, are devices. When we look at the metadata that we want to get from devices, it's things like names, type, trait, attributes, and state. If you combine these three elements, you start to see how we're building our understanding and our contextual relevance to help users get to the exact control that they want. So we launched this last year. How have we been doing? We have over 400 partners who have used the Smart Home API on Actions on Google. We hope that number goes up and some of you guys leave and start to also create some of these integrations for us. The other cool part is we control over 5,000 smart home products on the market today. So if you walk into any of your favorite electronic stores or any of your favorite sites and look at these smart home devices, there's a good chance that the Google Assistant actually can control it. But we're seeing an evolution. When we first started this, I remember talking to David, and we were all excited that we can say, turn the light on, turn the light off. We were like, oh man, we did it. We just changed the world. Like, it's our Edison moment. But what we realized very quickly that on and off wasn't enough. We wanted to be able to have the user speak to the assistant in the way that they speak to their partner, their spouse, or their children, or their family. And this evolution is a very simple thing from saying, turn the temperature to 72 degrees versus make it cooler, make it warmer. And how do we achieve that? The first step that we took was we decided to make sure that every single device, we actually support it directly, so that we had a deep understanding of how that device works and what are the actual traits that we need to create so we can match those to the grammars that the user will actually want. So 2016, we had a very small start. We had 4 devices. But you can see in 2017, we brought so many devices to the market that we support directly, and we understand with deep knowledge from cameras, doorbells, washers and dryers, sensors, air purifiers, refrigerators. There's tons. But we're not done. There's a bunch more in 2018 that we're bringing, all the way down to tubs and toilets, right? There will be a day where you talk to your tub, believe it or not, and there's a trait for that, and David will tell you about it. But let me just walk you through really quickly, how are we using all this data? How are we using AI? How are we using machine learning to actually create a better user experience? So this is a very simple graph. But if you think about this light, to the user, to a 5-year-old, they point at it and they say, "Mommy, Daddy, that's a light." What we want to understand about that light is a little bit different. We want to know, what's the name of that light? What traits does it have? Does it support on-off? Does it support color, brightness, state? And where's its location? Because that allows us to take the right action when a user says, make the lights in the living room, dim the lights in the living room a little bit, or make the lights in the living room brighter. Because what we're doing is we're going back to that home graph and we're saying, what's the name of that light? Where is it located? What's its current state? What's its current brightness? Oh, its current brightness is X. We'll raise it by Y. This is how we are starting to really take this data that we're having about the home and devices and its contextual awareness and make it a better user experience. But it just doesn't stop with lights. Lights is easy. Think about all the other devices in your home. So you'll be able to say, hey, Google, raise the temperature a little bit. Hey, Google, is the front door locked? Hey, Google, do the laundry. Hey, Google, dry my clothes. Or hey, Google, start vacuuming. Those last three remind me a lot of like me being my mom's assistant, right? It's like, hey, clean the house. But these are the type of things that we believe you will start to see from the Google Assistant because we've built this really cool backend with contextual understanding about the location and environment and deep understanding of devices. To give you a little bit more about how, as a developer, you can take advantage of this, David will walk you through Actions on Google.
Cool. Thanks, Mark. As Mark just noted, we've spent the last year really expanding this platform. We launched it a year ago at I/O. We had, at the time, maybe a dozen, 20 partners. And now we're, as Mark said, 400 partners, 5,000 device products. We've also got tens of thousands of developers playing with this. And a little later, I'm going to talk about how we actually do that. But first, I'm just going to walk through a little bit about how this works. We do a cloud-to-cloud integration. So for most of our partners in the IoT space, they've already got a cloud. They've got app control. They've got devices that are wired to their cloud. And so it's very, very easy to take that cloud integration and plug it into our lightweight API. Most of our partners here, we say, integrate within 6 weeks. That's end-to-end from start of project to launching to partners. It includes testing, it includes evaluation, it includes whatever we need to do to make sure everything's good to go. We have partners that actually do the work in under a day because in many cases it's just that easy. And as Mark said, I'll go into a little more detail. We use these concepts called types and traits. The reason we do this, we don't say this is the platonic washing machine. All washing machines aspire to this ideal device. Instead, we say there's a type of machine, a type of device called washing machine. For that it's a washing machine type tells us a little bit about it. It lets us learn that we can call it a washing machine. We can make it look like a washing machine. It's like a washing machine is like a duck in that regard. But that doesn't tell us what that washing machine does, because each washing machine has its own state, its own settings. One of them has a permanent press mode, and one of them doesn't. One of them has steam, one of them doesn't, and so forth. All of that is where we go to traits, and we use traits as the building blocks of the smart home. And this lets partners innovate in their own way, in new ways, which is what we did at our demo. If you go to our Sandbox, they have a mailbox over there. We have a somewhat dumber mailbox here on stage. I'm going to show you how we build this later. But this mailbox in the Sandbox, no one of our partners has built a smart mailbox before. But we did this for the demo because all the traits were there. Camera, light, on-off for the light, the toggle for the flag, object detection for mail. Completely innovate a new device based on the existing functionality we have. And because we all put this in the home graph, and the home graph understands context, understands state, understands change, and as you can well imagine, a lot of the Google secret sauce in machine learning and intelligence starts to operate on the things we learned from the home graph, we start to be able to take all of these devices and actually truly make the smart home smart. All of this today you can integrate with one API. It's very simple. I'll show it to you later. You integrate with the cloud. You integrate a couple of commands. You let us query devices. You let us execute devices. You tell us the devices are there. You can call us back at any time to do notifications, to push us state changes, to change the devices. So that's all you do. One little RESTful API. We have reference implementations we'll show you, and lots of documentation, a full team of developer relations and support engineers to help you. And you don't need to do grammar, you don't need to do internationalization, you don't need to do UI. Everything else like that is provided for you. And as you can imagine, with all of the other devices we're going to be rolling out, that the same we do it all for you happens on smart displays and so forth as well. So this is sort of the status quo we're in today. I'm going to turn it back to Michele to talk about the fun stuff coming next.
Great. Thanks, David. So as Mark mentioned and David mentioned, we've spent the last couple years building this platform out. And now we're in a state where we're able to add a lot of new features to really build on the intelligence and help you guys create better and more integrated and interactive experiences. At the end of the day, what we all want to do is create solutions to problems that people have in their homes, things that they're going to use every day. And so the fundamental features that we're adding over the course of this year are going to help you do that. There are 4 main features that we're adding for the rest of this year. Something called request sync, report state, new object detection trait that David's going to show you, and some new things for entertainment devices. So let's start with request sync. Request sync is really very simple. Right now, if I go to the store and I go buy another half dozen smart lights to go put in my home, I have to add those devices, and they don't necessarily, the fact that I've added those devices don't necessarily get synced up onto the partner app very quickly. And so what we're doing with request sync is you push the state to the Google Cloud to let us know, actually it goes into Home Graph, to let us know that these new devices have been on board. So I go out to the store, I get my new devices, I screw them in, we bring them, I pair them up, get them going, and they automatically just work. Today, if I did that, I would have to unlink and relink, and that's a real hassle for most users. And so we've taken that uncomfortable step out for users, made it easier for you, and made it a lot easier for your customers. I think one of the most painful points of smart home for a lot of new users is just getting started, even with things like lights. So making that onboarding process simpler and easier is really important, and that's part of what Request Sync does. We've also added a new API for report state. Report state is really important, and I'll tell you why it's even more important than ever. I spent a lot of time talking to a number of you in the Sandbox the last couple days about why we need report state. So imagine a situation where you go up and you change your thermostat on the wall. Go up, I shift it from 65 to 72. What we normally do on the back end is we poll you to figure out when that device has been updated. But you guys all saw the new displays and the new user interfaces for the phone in the keynote. Well, now we have new user interfaces on these smart displays and on phones that will show the devices. And with report state, when you push report state to us and into the home graph, we can get that state information instantly. So there's no cognitive dissonance between, I just went over and changed my thermostat, and my smart display is still holding an old state of temperature information. So report state is very important. It's one of the things we're starting to require our developers to give us so that we make sure that that user experience for our consumers is spot on. The other reason you want to use report state is so that we're not polling you all the time, which can get annoying and puts a lot of load on your server, especially if you have very active devices. In the future, report state is going to allow us to unlock a lot of intelligence. The state information that we can get, we can work with you together to start creating more intelligent experiences, like understanding that in the kids' room, the light is turned out every night at 7:30. So maybe we should just do that for you. So report state's really important now to make sure we have great experiences for our consumers, and it's going to be really important in the future as we start building more and more intelligence. So the next feature I want to talk to you about is object detection, and this is one of my favorites. This is actually a trait. We originally built this trait actually a few months ago. If you're familiar with the Nest Hello Video Doorbell, you may know this feature. And it will actually let you know someone's at the door. And we did that integration using the new object detection trait. Let's take a look. See if I can. Here we go.
Someone's at the front door.
Okay. So if you haven't seen that before, a simple push of the button, and it notifies out on the Google Home Mini through the assistant. What's really cool about this trait is that it actually changes the model. And this is one of the things I really want to stress with you. What we're trying to do at Google is give you guys the ability to create more interesting integrations. So with the object detection trait, normally the assistant controls the device. You say, OK, Google, turn on the lights, right? With this, you take an action on a device, and it tells the assistant to give a notification. Oops, I just fired the assistant off, sorry. So David's going to come out right now and show you a little bit more of what you can do with object detection.
Cool, thanks. So I'm going to do a demo here of how notifications work. Object detection is actually a specific case of a general facility we're adding to the smart home where partners can send notifications on objects. And notifications become another aspect of objects and devices that you push into the home graph, just like traits and attributes and states and commands and so forth are aspects of devices. In this case, notifications attached to traits. So just like in Java, where you have an object and the object might receive messages, might declare the errors it throws. When you declare a trait, you also are saying, hey, this. For example, this washing machine supports a run cycle, therefore it can now send/receive, depending on your perspective, notifications of cycle errors. The washing machine has failed during the rinse cycle. We've built this object detection as our first case of this, and like the video showed, we built it, first use cases, doorbells, but we build these things as general cases. The example in the lab, in the Sandbox, is for mail detection, and here we're going to build something a little more interesting. But we're going to show you, how, I'm going to go back, recapitulate a little bit, register a smart home project, show how linking works, show how you can deploy your cloud service here or elsewhere, how the notifications are sent through, in this case, Node.js and Firebase from the device itself, and finally show you some code, show you some debugging tools. This is basically the flow of this demo. So this is a smart mailbox. It's really a pretty dumb mailbox, but it has a very smart Raspberry Pi down there that has some sensors wired into the box. Again, not a shipping product, but an easy demo that as a maker you can build something like this. The mailbox has a cloud service that we have on Firebase. It sends a notification of it's in whatever protocol. It's in this case it's a GET request to the payload that this sends to our cloud service. Cloud service is where the smarts are. Cloud service is also part of our API. It calls the assistant with a one platform API call, sends the notification. The notification then goes into the home, or goes directly to the Google Home I have up here, and we'll see that demo. And of course, all of this is driven by the fact that initially, and I'll show you the code for this, initially the mailbox and other devices were synced from the partner service to the assistant for my demo user, and therefore in the home graph we know that this device supports actually, technically it supports everything that the one in the Sandbox does. The flag, the lights, the camera, and so forth. There's actually no camera in here, unfortunately. But all the traits are there. So I am going to hop on, I'm going to hop on over to the laptop screen here, which of course locked on me. Great. So some of you saw this last year. We have rebuilt this quite a bit. Last year, we were doing a demo that was largely at the command line. You need no command line functionality for this now. Those of us like me that missed the command line are a little sad. But for the vast majority of people, we are now entirely using the actions on Google Console. So no more G actions, writing action packages. This is much more native for us. So I'm just going to walk through a very simple example, and we're short on time, so I'm going to do this very quickly, of how you build a smart home project today. So I'm going to add a project. Now, if you're doing this, you pick a project name. Recommendation, pro tip from what we've dealt with partners, pick a name that makes sense. We're no longer auto-picking names for you, so you don't get something like Purple Chaos Giraffes. Pick a name because you're going to be using this with us later if you deploy this to production. So that said, let's call this Purple Chaos Giraffes. That's why not. And let that create spin, 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 very slow because I'm on stage and it knows I'm on stage, so it's going to slow down. This is creating a project in the Actions on Google console with my Google account up here. Wow, it really is slow. Now I have all these things. This is the full Actions on Google panoply. So I could build a shopping app, or I could build a chat app, or I could build, a quote of the day app. All of those are using conversational actions. But for smart home, we are really recommending and very strongly recommending that you're using these APIs, because this is what gives you home graph and notifications and full understanding. And so today, the setup is in fact very quick. To get up and running, this is going to take only a couple minutes. So I'm going to name this something random. And I will then and forgive me, my network is especially slow today. Account linking. Many of you have done this already. OAuth is the mechanism for account linking to existing service clouds. This is pretty standard OAuth. Nothing out of the ordinary here. I'm going to make some keyboard mash keys. Do not use these keys at home. And of course, that is protected by RFC. Did you know there's an actual RFC protecting example.com in perpetuity? No one ever knows that, but it is real. And testing is awesome. And at this point, we are pretty much set up. We're going to go ahead and create an action. I am going to give it, I need exactly one thing. I need the endpoint for the action. And again, this is a demo. I'm not going to set this one up. I'm going to switch to the one I have set up. And at this point, I have now deployed this, and this will show up on my phone. Actually, I have not. I have now deployed this, and it will show up on my phone. And it will complain because I don't have the URL set up for OAuth. But this is now set up on my phone, and will be available in a second to show that. But instead, I'm going to switch back over here to my stage demo project. This is the one we're actually using. Here I've got the action set up. It's pointed at a Firebase app. And the Firebase app here is, I'm going to show you the Firebase app. You can deploy, we get asked this question a lot. Do I need to use Google Cloud? Do I need to use Android Things? Do I need to use Weave? Do I need to use Thread? Google has, as Google always does, a number of technologies that you can use to be a completely full stack Google developer in everything you do. And if you want to do that, that is awesome. But it is completely and totally not required. If you have an existing cloud, you can keep it. You can integrate this with any infrastructure that you want. You just need internet, decent security, OAuth, and implement our lightweight JSON API. In this case, we've done this demo using Firebase. It's a Node.js app. It's using the Firebase database, as you can see, to actually do all of the triggering. You can see our trigger types here, or our traits here right now for object detection. And so on and so forth. That is how we implement in Firebase database the actual representation of the commands that we run this through. And so I'm now going to show you a little code. We have this implemented as a Node.js application. This application is a slight variant of the one that's in the code lab. So if you go over to the code labs by the front of I/O, there is a smart home code lab that's building a washing machine. It is very much this code. This is also on GitHub. So you can play with this yourself and use this if you want as a reference implementation. This is not a full, you would not want to use this as it is for your IoT product in market because it doesn't have a persistent database. It doesn't have a lot of the user handling that you'll want for obviously your own product. But it does a full reference implementation, including a lot of these traits here. And so just to show you a little bit, what we're going to demo here is primarily object detection, like Michele said, but instead of doing mail, because these things are extensible, I'm going to show you how you might build a product that detects, like in my neighborhood, we have some other needs for this sort of thing, and I'll show you how that works. But first, let me show you how you declare this. So we have a sync handler. The sync handler is basically just, this is all Node.js. It's simply building the payload. That's actually remarkably uninteresting. The device list here in the reference is building devices. So this is a fixed list. You run this, and because there's no database, it defines a number of objects for you that you can use for tests. So here's, for example, a washing machine. As I was saying, this washing machine implements on-off and start-stop and modes and toggles. So it's going to have modes for permanent press, hot, cold. It's going to have toggles probably for quiet mode or bleach mode or whatever. And it has a sensor built in. And then we've built down here somewhere a mailbox. Of course, that's the next one. And here you can see these are all the traits that we have used, including the outgoing mail toggle here is a toggle. We just have a special code for it because you have to do attributes for toggle. This is all the things that the light in the box and the sensor and the flag and the detection and the camera stream support. And to see all of these in action, go to the sandbox where the camera is working and the flag is working and so forth. And with that, let me show you the notification. The notification in this case, again, Node.js, very simple. It's taking a pass-through from the payload, from a HTTP endpoint that the box calls our implementation in Firebase. And it simply then has, ignore the hack line, it simply sends this notification back through, where is it? The report state and notifications use the same call. This uses a Java web token to call us at any time. It's how you do sync, it's how you do state reporting, and it's how you do notifications. And so this is running. It's running in Firebase. I am going to show you, if you can switch to my phone for just a second. Oh, fast. I'm going to show you. I've already set this up, so I've already connected to this agent. You can see I've got all the virtual devices that this one advertises, which are the devices in the sandbox. But I've got the mailbox here. There are actually no commands on the mailbox right now. But I want to show you object detection. Object detection in this case, like I said, we implemented, instead of doing mail, we implemented animal detection because object detection could detect anything, doorbell, face recognition, whatever. This was supposed to be originally a live demo, live animal demo, but our lawyers said no, that was a liability, and I was being grossly irresponsible. So I'm afraid this is no longer a live animal demo. But could I get the mic turned on the Google Home? Thanks. So, not a live animal demo. I apologize. But if all works well.
There's a raccoon in the mailbox.
So, kind of a lame. Kind of a lame demo. We were reusing the detection logic for mail, and it's a little harder on fuzzy animals because it's not fuzzy logic. So it's a little tricky there. But you can see, just like with the Nest facial recognition, which, to be fair, is many, many, many more thousands of engineering hours of time than that raccoon demo. But you can see, you as an IoT partner can do what you do best. You build a cool device, and we'll handle all the grammar, the understanding, the notifications which go to, now you have access to the ecosystem in the house. You don't just send messages to the phone. You can do notifications around the house of interesting things, and we'll see over the coming weeks and months, we'll be adding notifications of a lot of different types to existing traits for security events, safety events, other notifications. You can imagine, when the oven timer is going off, you're in the other room, you want to know the roast is done. Those sorts of notifications are available, and you can now be two-way into the smart home ecosystem. And these are things that will be rolling out significantly over the coming months. Like I said, this reference example, by and large, minus the raccoon, is in Git and in the sandbox. You can do this with all of our ecosystems, you can run it on, this is on Firebase, run it on your own cloud, run it on, I know some other companies out there have clouds, I forget their names, but you can run it wherever you like on your existing infrastructure. You can run anything you want on your client. We do have Android things, and you should absolutely, in this space, you should go and see the Android things sandbox. There's some very cool stuff. We have some cool projects where you can easily integrate Android things with the smart home ecosystem. We'll be doing a lot more of that. Someone just showed me this walkthrough. This is actually last year, but this walkthrough you can find by searching for home automation and Android things. Somebody did a very easy walkthrough demo of Android things running directly with the API, and you can do that walkthrough. We also have several open source projects natively integrated today. So over here we have Home Assistant somewhere. Where are they? Home Assistant right there in the middle, has.io, and we have OpenHab, which are both right there in the middle, which are both open source platforms that are already integrated. So if you want to play with smart home devices and don't want to implement this awesome API, you can use those for your projects as well. Last thing I wanted to show in a developer tool, because this was something that we've been asked for extensively in the last few months, last 6 months, is we have done a lot more work to integrate developer tools into the Google ecosystem for smart home. So this here is the stack driver. Oh, can you switch back to the laptop? Thank you. So this here, if it's hard to read, I apologize, is the stack driver for this account. So here's the IO stage demo. I've logged into stack driver, and all of the errors that we see on our side, and I had to generate some yesterday to get this, but last week, all of these errors are things that you would not see because they're outside of your ecosystem. If we call you, make a call to the mailbox and you hit your server and the mailbox fails, you know. But if an OpenAuth is failing, if sync data is wrong, if the notification that you send can't be delivered after you've given it to us, all of those things are errors that we don't have real-time reporting. So they're now going into Stackdriver. You can integrate this with your service. You can use this with debugging. You can pub sub from Stackdriver. If you have another logging service, you can subscribe to your Stackdriver alerts, directly integrate them with your logging. And all of that is now available and highly recommended. Makes the development process much easier. That's really end-to-end on the demo. Like I said, please visit the Smart Home Sandbox. We have lots of more demos like this there. Talk to us. We have our development team ready to support developers. We have folks answering questions online. We have other events like this. And throw us your questions. We have a dedicated team of folks just building new traits, building new device support every day. We have a lot of stuff that is available but not yet on the public website. So if you see something that you want that's not there, talk to us. It's probably something we already built. And if not, we'll probably build it for you. So talk to us. And with that, I will turn it back to Michele for one more thing.
One more thing. Thanks, Dave. That was awesome. Does the raccoon have a name?
Sorry?
Does the raccoon have a name?
The raccoon's name is Craig.
Craig.
Yes. We spent significant time on this yesterday.
Excellent. I'll get the backstory later. So we do have one more thing. So we are announcing here that we are also opening up new APIs for control of entertainment devices. And if you've been to the Sandbox, you've probably seen the demo that we have in the booth of the Dish Hopper box that's currently working in there. That's our first implementation. That'll be launching in a few weeks. We'll take a quick look at it for those of you who haven't been there yet.
Okay, Google. Switch to HGTV on the Hopper.
So there we go. It's switched to HGTV.
Okay, Google. Switch to ESPN on the Hopper.
There we go. By the way, that's Mark's and my cool little setup in our office of the mini smart home. So these new media or entertainment device APIs are meant for devices that aren't Android TV and are not cast enabled. And there's millions of them out there, like the one in my living room that's a smart TV that has no voice interface, there's no mic, there's no speaker. And what we want to be able to do is light up the assistant to make home control easier for those types of devices. So what we've done is we've announced a set of traits. And this is the list of traits we have specific to entertainment devices. So we have transport control, gives you the ability to move the media, rewind, fast forward, et cetera. Change the volume up and down, get the state of the media, do recording, understand what channel you're on. You heard Mark switching to the channels. We played a lot of ESPN yesterday. And in some cases, we are also doing media initiation, and this is by early access partner only. So if you happen to be at a company that's doing entertainment devices, please come talk to us. We'll be in the Sandbox and happy to talk to you more about this. One other thing that I wanted to mention in addition to our APIs, and just touch on lightly, this was slightly covered in the keynote, but we now have a number of surfaces in which your smart devices will be shown. So not only through voice control on a variety of speakers, but now on the phone, you'll have the new Assistant app that will show the status of your smart device on the phone, and also on all of the new intelligent displays. So multiple surfaces for your smart device to be displayed on and interacted with. So Mark mentioned this earlier, that we're up to 400 partners and over 5,000 devices. These are just some of the partners that we've launched since CES, which was in January. So we're growing very fast. We've added new partners like LG, Dish, Hisense, Vivint, Xiaomi, Panasonic. A huge variety of partners have been coming on with really interesting integrations. So if you're thinking about getting started in smart home, please come talk to us. As David mentioned, we are in the Sandbox. We're in the Google Assistant Sandbox, which is Tent A. We also have a code lab going where you can go try this out for yourself, do some of the coding that David just did, get your basic project up and going. If you are already a developer with us in Smart Home and want to understand more about report state, we've got a code lab on that as well. And we will be hanging out in the Sandbox after this, so please come and talk to us. Thanks very much.